Mean imputation is what it sounds like. We're going to fill in each missing value. So we're not just going to drop them, and we're not just going to make a missingness category. We're actually going to fill in guesses of the missing values. We're going to fill in each missing value with the mean of the observed values for that variable. So for example, for education, anytime anybody, for the age and education example, anytime anybody's missing education, I'm just going to fill in whatever the average education was for people who did answer the question. Okay. So, okay, when is this useful? It can be useful to avoid dropping units. So avoiding dropping rows, right? So if you think of this example where there's 100 different variables, and anybody who's missing on even one of those variables is just going to get dropped from the data set, it might be appropriate just to fill in something, just so that everybody doesn't get dropped. So again, imagine there's 100 variables, and each of them only has a few people who didn't fill it in. Probably you're not going to change your answer too much by filling in the 2 or 3 missing responses on each variable by the average of the responses that you did observe. And you might be able to avoid having the size of your data set. So let me say this another way, right? So you can use this useful if the data is missing rarely. And you really need to move forward, and you're trying to move forward. So this is not the best or the most thoughtful way to make guesses, but it is something you can do. If you want to get to the next step, right, and you just need an analysis, even that analysis isn't perfect, you're trying to get something done, right? This can be a useful plan. One thing that's nice about it is it maintains the observed means. It maintains the observed means. What do I mean by that? Well, if the average education value among people who did answer the question is 14 years, and you fill in 14s for anybody who didn't answer, then the average, including the values you guessed at, is still 14. Or the average of a bunch of values with mean 14 and a bunch more 14s is still 14, right? So that's a nice feature, okay? Now, this is okay, right? Not ideal maybe, but it's okay if the data is missing completely at random. I'll say not ideal. Because if the data is missing completely at random, then your observed mean, the mean of the observed values, is a pretty good guess at the estimand, at the overall mean, because there's nothing special about the values that are missing. So the fact that the mean imputation maintains the observed mean is okay if you have completely at random missing data. If you have missing at random, missing not at random, then you don't like your observed mean, right? It's probably biased, so it's not great that this maintains it. But there's something else, right? There's something else about the variance, okay? So I want to write it here. This method underestimates the variance. And I want you to think about why.